Today we are talking about torsional pendulum. Torsional pendulum is frequently used. It is simple. It is like a simple pendulum, compound pendulum. A heavy circular disc or a cylindrical disc fastened at its center of gravity by a thin and long wire which can rotate about a vertical axis, passes through center of gravity and capable to oscillation in horizontal plane. Oscillation in horizontal plane. Is torsional pendulum. A heavy cylindrical disc or a circular disc fastened on its center of gravity by a thin and a long wire which can rotate about a vertical axis, passing through center of gravity and capable to oscillate in the horizontal plane, is known as torsional pendulum. When a disc is rotated through angle theta, then wire twisted by theta, which provides the restoring torque. This provides the restoring torque. This torque keeps oscillation so the motion of torsional pendulum is in angular simple harmonic. The motion of torsional pendulum is angular simple harmonic. Restoring torque is directly proportional to the angle of rotation. Restoring torque is directly proportional to the angle of rotation. Restoring torque is directly proportional to the angle of rotation. That is, restoring torque tau res is directly proportional to theta. That is, tau res directly proportional to theta, or restoring torque is equal to minus c theta, where c is a constant called torsional constant. which value was determined by another derivation which is not considered in here. The value of c is given by c is equal to pi r4 eta upon 2l, where eta is a modulus of rigidity. R is a radius of radius of wire, and L is a length of wire. Eta is a modulus of rigidity, R radius of wire, L length of wire. Now applied torque is given by I alpha, where I is a moment of inertia and alpha is a angular acceleration. Applied torque is equal to I alpha is equal to I d square theta by dt square theta, where I is equal to 1 by 2 m r square. R is a radius of circular disc and m is a mass of circular disc. When no external agent are applied in this system, then applied torque is equal to the restoring torque. Applied torque equal to restoring torque. Applied torque equal to restoring torque. That is I d square theta by dt square is equal to minus c theta. D square theta by dt square is equal to minus c by I theta, or d square theta by dt square theta plus c by I is equal to theta. C by I theta is equal to 0. This differential equation of motion is similar to the equation of simple harmonic motion, that is d square theta dt square plus omega theta is equal to 0. By comparing we get omega square is equal to c by I, or omega is equal to root under c by I. We know omega is 2 pi f, so 2 pi f is equal to root under c by I. Therefore f is equal to 1 by 2 pi root under c by I. Now for time period, we know time period is equal to 1 by f. Therefore time period becomes 2 pi root under I by c. Let's say it should be the equation 1. T is equal to 2 pi root under I by c, since the moment of inertia and torsional constant both are independent with the value of g. So time period of torsional pendulum is independent with the value of g. Time period of torsional pendulum is independent with the value of acceleration due to gravity. Time period of 10 torsional pendulum is independent with value of acceleration due to gravity. Since moment of inertia and torsional constant both are independent with value of g, so time period of torsional pendulum is independent with value of g. Now moment modulus of rigidity. Calculation for modulus of rigidity. Calculation for modulus of rigidity of the wire. We know C is equal to pi r4 eta by 12 and T is equal to 2 pi root under I by C. Now T is equal to 2 pi root under I by C, squaring both sides. T square is equal to 2 pi 4 pi square I by C, or T square is equal to 4 pi square I by C, or C is equal to 4 pi square I by T square, or pi r4 eta by 2L is equal to 4 pi square I by T square, pi cotted. Eta is equal to 8 pi IL upon R T square. Means the required expression of eta is 8 pi IL upon T square R4. This is the required expression for a modulus of rigidity of the wire. Modulus of rigidity of the wire. And by this method we can calculate time period, radius of rigidity of the wire in case of torsional pendulum. First we define the torsional pendulum and we calculate the time period, and then we calculate radius of modulus of rigidity. Now this much for today. I'll give one question to solve for you. Solve it and the question is the metallic mass of 0.5 kg and radius of 0.5 meter is suspended by a wire of length 40 cm and radius 1 mm. The torsional oscillation of the discs are found to have period of 2.5 seconds. Find eta or modulus of rigidity. Answer comment below.